Okay, so this video we're looking at solving quadratics again, but this time not by factorizing, but graphically. So previously on the last video we looked at solving quadratics by factorizing. Now we're looking at solving quadratics graphically, which is where you're literally given the graph of the quadratic and you can see the solutions of the quadratic, a bit like in this example here, but it isn't always as easy as that. Okay, so we'll get straight into it. So we'll go through 3 examples and then that will be it for this video. Right, the first one says, using the graph below, find estimates of the solutions to x squared plus x minus 1 is equal to 0. So what this really means is, right, this bit here, this x squared plus x minus 1, if I put it equal to y, like I've done here, that produces the graph that looks like this. Okay, so this red U-shaped quadratic. And because it is just equal to 0, that really means, right, y is equal to 0, which is just the horizontal line that goes along the x-axis through 0 at y equals 0, along there. Okay, so that's why we're just looking at these 2 points here, where it cuts through the x-axis here and here. And it's an estimate, so approximately it's going to be, that's 0.25, 0.5, it's about 0.6, and it's an estimate, so there's going to be a bit of variability in the answer. But approximately, I can say that x is approximately equal to 0.6. That just means approximately, okay, approximately equals to, in the exam that they would give that to you already written down, but I've written it here. And your second solution is going to be approximately, if that's minus 1.25 minus 1.5, I would say minus 1.6 approximately. So I can say my second solution is going to be approximately minus 1.6. And there we go. Okay, so these are my first 2 answers. There we go, and there we go. And they're just estimates. Okay, so it doesn't have to be that accurate. Well, it does have to be accurate, but they're estimates. Okay, example 2. Using the graph below, this one's a little bit different because we can see this time your quadratic, which is this thing here, which if we put it equal to y, we get this red quadratic here, but this time it is not equal to 0, it is equal to 2, which is really saying, where does that quadratic here cut through your line, y is equal to 2. Okay, and that line y is equal to 2, if I go and draw it in blue, is going to go through y, which is this axis here, at 2, and it's going to be a horizontal line that goes through that point 2. So this time we're looking at the solutions where they intersect the quadratic and the line, which is here, and we're looking at the x values which they do that, which are going to be minus 3, and also, sorry, it's not where I need to towards it, 1. So my 2 solutions here are going to be, let's keep it in red, and this time it is not estimates, they're just whole number values, so x is equal to 1, this one here, and this one down here is minus 3. So x is equal to negative 3. Okay, and that is it. Those are my answers there. So x is equal to 1 is one solution, x equals to minus 3 is my second solution. Okay, last one, a little bit trickier, but nothing that we can't handle, so let's have a look at it. So shown below is y equals to x squared plus 3x minus 1. So again, if I put it equal to y, it produces a graph that looks like this. Okay, and that should really be saying that's the x-axis, and that is my y-axis. And it says, by drawing an appropriate straight line, use your graph to find estimates for the solutions of x squared plus 3x minus 1, which again is this red quadratic here, the same thing as this here, being equal to x plus 1. So this time it isn't 0, it isn't 2, like on the previous slide. Okay, we had 0 and we had 2. This time we've got this thing here, x plus 1. What does that really mean? That just means, right, we need to plot the line y is equal to x plus 1. Okay, this is saying, where does your quadratic y is equal to x squared plus 3x minus 1, this intersect or cut through y is equal to x plus 1. So I've got to go and draw this straight line on my graph. And there's different ways that you can draw this line here, right? If you're already confident with y equals mx plus c, you'll recognize that the gradient here is 1 and it goes through the y-intercept at 1. So you could plot it like that. But I always think, if in doubt, if you're not too sure how to plot a quadratic, right, table of values. So what does that really mean? So if I'm drawing y is equal to x plus, beneath y is equal to x plus 1. Let's go and choose some x values and plot them against the y values. So, right, let's just go for x to be minus 1, 0, and 1 to generate some y values. So minus 1, 0, and 1. And you just need 3 points to plot any straight line. So that's going to be absolutely plenty. Right, you could have chosen any x values there between minus 5 and 2 to plot this, but I've just gone for those 3 because why not? So when x is minus 1, put it into my equation, I'm going to get y is equal to, well, if x is minus 1, I'm going to get y is equal to minus 1, x minus 1 plus 1, which is just going to be equal to 0, so that can go in there. When x is 0, I'm going to get, well, x is 0, so 0 plus 1, which is just going to be 1. And when x is equal to 1, 1 plus 1 is equal to 2. Okay, I go and plot these points here. So minus 1, 0, x minus 1, y 0, x 0, y 1, and then last one, x1, y2. There we go. But there should be 3 points exactly in a straight line, which they are here. And then carefully, if I go and continue this straight line, right, we can see, because the gradient is 1 and it goes through y equals 1, we're just going up by 1 each time. Across by 1, up by 1. If I go and join these points together, right, really carefully using a ruler, obviously that's what you guys would do. I can't do that on my screen, but it works nonetheless. There we go. There we go. There we go. So this time, right, we're looking at where your curve and your line intersects, which is this point here, and also this point down here. And I want to find the x values in which they do that. So let's go and draw our point going down, and it is an estimate, so it's going to be, you know, an estimate. So let's go and draw those up as carefully as I can on my screen. But my screen, it's not very easy to do it, but that's going to be okay. It's quite hard to keep it straight on this. Good. So I can see, right, if I'm going up by 0.2, 0.4, 6.8, that's approximately, if that's 0.8, I would say about 0.75. Estimating it, right? It could be 0.7, it could be maybe something else. I would say this value here, this one, and let's go and draw that one there in red. So this is my x value. I would say x is approximately 0.75 for that one. This one here, I would say if that's minus 2.8, probably again I would say minus 2.75 is going to be okay. I would say x is approximately minus 2.75. But again, right, you could estimate it as minus 2.7. Yeah, as long as it's roughly within the range, that is absolutely fine. Okay, so those two values there are my answers. Approximation, so I've got these squiggly equal signs, and that is it. That is solving quadratics graphically. Thank you.